22, you've got x plus 6 for when x is less than or equal to negative 3, and negative 2x, negative 2/3 x minus 3 when x is greater than negative 3. Which means if you did it the way that I was showing you guys yesterday, by kind of doing that little imaginary vertical, something funky's happening around 3, okay? So if you did it that way, you would put in like your little highlighter around 3. Okay. I actually saw students using the highlighter to do that. I thought it was kind of a cool idea. If you didn't do it that way and you just wanted to graph both of those equations, and then go back and erase for those parts of the equations don't exist. That's another method of doing that. Okay? It's totally up to you and how you want to set it up. So if I go this route, I know that I have, if I look at my first graph, I've got x plus 6, and then that's an easy slope. And it's going to be 6 for y-intercept and a slope of 1. So I know it's going to go up and right or down and left. Oops. So if I go this way, and all I'm doing is just filling up the board with dots right now. I know that I really don't need anything to the right of my imaginary vertical line because it's telling me to take everything that includes the negative 3 and going to the left. Okay? Remember, it's just the x values that are going to the left. It does not matter that the graph is going down. The graph can be going up. The graph can be going horizontally. It just so happens you're worried about the domain, the left and right. Okay? So I know that this, since this is an underline, this would be a solid dot here, and I'm going this way because my x values are moving to the left. If I did make any other dots going the other way, I'm just, oops, no, I've done messed all that up. It would be that one, right? Yeah. And then you kind of erase yourself back. Okay? It's an easy way of setting it. Do the same thing. The negative 2/3 x minus 3, which means I start at negative 3. When I start at negative 3, I know I'm going to go down 2, right 3, down 2, right 3, because it's negative. Or up 2, left 3, and I'm here. And I knew that this problem was going to be an open dot because it's just a greater dot. And I don't have to go any more to the left because if I go more to the left, then I'm falling to the other graph. Okay? And I just connect my dots. Draw my line. Hello there. Okay. Yay! Do you have a dollar? I have to go. Got your dollar. Which one? 25. I'm guessing you'd like to see 25. Yes. Sure. 25. I like giving you guys ones that don't automatically fit cleanly, just because, you know, it's fun. Do 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 do. what the graphs themselves are going to look like. So let's walk through how do we do this. It's actually pretty easy. Oops. All right, that kind of works. So one of the things that I like to do when we're going through those is if I wanted to figure out which problems I'm at, first thing I would do is look at my domains, the domain restrictions, since this is just matching. You'll notice that you've got something changing at 1, 0, 1, 0, -1, and 1. So of those 6, there's only one of them that is itself. There's just one problem that changes at -1. Does everybody see that? So that should be the easiest one to figure out. You don't have to map anything just by looking at which one of those has something funky happening at -1. See? Okay, wait, no. Did you see what I did there? And you didn't get that in your Spanish 3? Dios mío. So we know right away that this one's easy to figure out because it's C. So we're going to eliminate that one. Okay? Now you go back in there, you have 2 of them that change direction at 0, and 3 of them that change at 1. So let's worry about the ones that change at 0. Let's try those first. Okay? Do you guys all agree that B and F are the ones that change at 0?
Yes.
Okay. Now, if I look at B, what value is the y-intercept? 4. Is it 4 for both graphs?
No, just 4 would be. It's 4, I guess that's 4.
So it's got to be 14, doesn't it?
Yeah.
See that? Without having to know how to map any of this, I know that both these guys here have the same exact y-intercept. By process of elimination, have I done any math yet? No. All I've had to be able to do is identify, well, that one changed at -1. There's only one graph that did that. That one changed at 0. Well, there's 2 graphs that do that. This one has the same exact y-intercept. Well, that's easy. That's B. So I don't worry about this one anymore, and I'm done with this one. Which means by process of elimination, what does F have to be? It has to be at 16, because if you look at it, you have 2 different intercepts. You have one at 3, and you have one at 4. Pretty quick and easy. All right. Now things get interesting. Now is when you have to try to figure out exactly what is going on with each one of them. So if I look at A, on graph A, you'll notice you've got a negative slope, and you have a horizontal slope. If you just know how to read the graph by just saying negative slope, because it's moving down and right, and you have a horizontal, there's no other graphs that look like that, are there? What's the only function given to you that has that? 18, very good. Yeah, 18 is the only one that has the horizontal line, the 0 slope. So right away, this one has to be A, so that means, again, have I mapped anything yet? The only thing that you have done here is just used some deductive reasoning by which of things that you know. Slope intercepts. You know how to find slopes-ish. You know how to interpret where things change direction. Okay. Now we're down to the last 2. The last 2 you have for what is it? Number 13 says x minus 4 and 3x. So if it's x minus 4 and 3x, that means that and it's changing at 1. One of them would have had a y-intercept of -4. One of them would have had a y-intercept at 0. Well, if I'm just looking back at my graphs, the only 2 that are left is at D and E. Well, the scaling here, they're going by 2s. Okay? Well, this one looks like it goes through a -2. This one looks like it goes through a -4. Well, let's see then. That's a -4, and the other one is a -2. Gee, which one's which? Everybody see how I'm doing this? I'm just looking at the scaling of it. I'm not having to math anything, okay? So the idea here was I could have had you guys do that, but you guys probably were all freaking out going, I don't know how to do any y's and what to do. did I once look at the inequality, except for where things might, where the funky stuff happens? No. Okay. So in essence, when you get to stuff like this, you actually know how to do it, especially if it's catchy. That should be the easiest stuff in the world. But what happens when it's not? What are you going to do when you have something that looks like, oh, quit your whining. Always worry.
It's Tuesday.
would, he always had to say something like, dogs love trucks, and stuff like that. Absolutely. But yeah, it was just, I thought it was, don't know why I brought that up. Whatever, it's just kind of fun. Anyway, you're okay with drawing and writing equations?
Yes.
Cool. So let's talk about the other thing that we haven't gotten to yet. So if you got your graph paper, this is what we're going to call a step function. Okay? If I say something is going to be called a step function, that kind of means that the graph is going to look like a bunch of URSMRT. Okay. Now, if you look at it, how many steps does this problem have? 4. Now, when we look at this, step functions, last time I checked when you're walking up and down stairs, stairs are always horizontal. They're always parallel to one another, aren't they? I would hope so, unless they're poured badly and you might trip and fall and bad things happen. But, what's that? All crooked? Not good. You can roll an ankle. Hey, yeah, it's keeps you on your toes. Dance studios. I love that. We missed you. Yeah. Anyway, so the first horizontal line is going to be located where?
Between 0.
Correct, but what's the equation going to be at? Yeah, 1, right? Okay. F of x equals 1 is a horizontal line through 1. Do I include 0?
Yes.
Yes. Okay. So I include 0, which means I put a solid dot. And what do I put at 1? An open dot. Oh, I should have changed these parameters, spaced this out a little bit. And I connect the dots. What happens at 2? Include 1 and you exclude 2. And there's your step. This is the exact example that I was talking to you guys about the other day. We talked about prices at a buffet. Kids under 4 eat free. So from 0 to 4, they're free. From 4 to 8, they're $5. And then from 8 to 60, they're $9.
Yeah.
And then from 60 to dead, or we should say less than dead. They're back to $7. The idea here is that you've seen this before, but you never thought of it in terms of what it would look graphically. It's pricing at movie theaters. Kids pay a price, sometimes students pay a price, adults pay a price, senior citizens pay a different price. It's pricing levels. It's pricing levels depending upon sometimes where you sit on an airplane, things like that. If you go on a cruise, different tiers on boats have different pricing levels. That's what this looks like. Okay. This one should be fairly simple to work with. The only thing you got to be careful with is your open and closed dots, depending on what side they put them on. You just got to read it carefully. Also, sometimes they'll do it in terms of a larger boundary. Whereas in this one, I should have done first because it spaces it out a little bit. That way, it jumps around with your stuff. Again, we have f of x equaling 4, 5, and 6. Could you have a step function alongside linear stuff? Absolutely. You could have it goes up to a certain price, it plateaus, and then it drops. Things like that. That does occur as well. These all, as weird as it may sound, these do actually occur in real business type situations and whatnot. Maybe a little bit more complicated, but in essence, if you think of it in terms of buffet, it's very simple. So if I got 4, 5, and 6, I have. Sorry, so I can see it. I know that at 4, it's between 0 and 2. Does it include 0? Why? It's got the less than or equal to thing. So at 4, I have a solid dot, and it goes until 2. Open, connect them. And then I jump to 5, close dot on 2, open dot on 4. Then I go to 6. And there you go. Hopefully that's not too terrible. It really doesn't. Step functions are actually fairly simple. I just didn't want to try to cram all that in as well as ungraded equations yesterday. I didn't think there was a need to try to slam it all in at once. There you go. Had we not done the skill check stuff, we would have been able to get all that in, but that took 10 minutes, and we could have done a couple less examples of the other stuff.
Skill check.
No.
What? Oh, you want one?
No.
Do you have one?
There's usually one
That's true. If I make this gum wrapper in the ground.
Why does it make sense? Because you're trying to find the pattern? Nope. There is no pattern. There is no pattern.
If I make this in the garbage, it won't work.
Today's Tuesday. Let's see. So let's do this. You've done those graphs. For homework then, or add to what you have, you still have some room on your graphs, I would assume, right? So you have some graph paper? Okay. What I'd like you to do is the same section, the next page over, it's got, we'll do 27 and 29, and then I want you to write the equations for 35, 36, 37, and 38. Okay. Now, real fast, I want to show you number 35 and number 38. I'll pull this up here on the board so I can show you guys what I'm talking about in terms of the graph. They don't do a very good job of how they do solid. They're changing direction at one point, so they don't normally, you know how I've been overdrawing the over circle over the second graph. What I want you guys to do for stuff like that, whenever you see a graph that looks like this,